question goes like this. N concentric thin conducting shells having radius r by 2, r by 2 square are placed as shown in the figure. The innermost nth shell is earthed. If Q charge is given to the outermost shell, find the charge on the innermost shell. I suggest you pause the video and try to do this on your own. This is not a difficult question, but many students get lost due to this large number of shells we have. Try to do this and see how your method compares to the solution. We now go ahead with the solution. Now here I have shown the portions of the shells so that the diagram does not become cluttered, and I have assumed that X charge is present on the inner surface of the outermost shell, therefore Q minus X is present on the outer surface. By Gauss's law, on the next shell, minus X charge will be induced. And since this was already neutral, it had no charge, therefore plus X charge will come onto the inner surface of the second shell. And this will continue in series for all these shells till you reach the innermost one, where you will have minus X charge on the outer surface of the innermost one. Now, one thing to realize in this question is that all the shells other than the innermost one and the outermost one are neutral and therefore have no potential contributions. You can see each one of them has minus X and plus X. Therefore, whatever be their charge distributions, we are really not bothered with that. And to find the potentials, the only charges that we have to take care of are Q and minus X. The total charge on the outermost shell is Q and that on the innermost is minus X. So since the innermost shell is earthed, we want to equate the potential of that to 0. How to write the potential for this one? To write the potential, we must take care that potential of the innermost shell is not only due to its own charge minus X, but also due to the contribution from this plus Q. Many students only write the potential due to its own charge and forget the contribution at that location due to surrounding charges. That is a big blunder, and that is why many students fail to get the final answer. So make sure that whenever you are writing potential of any system, you write the potential of the system due to its own charge plus potential due to the contributions from surrounding charge. Going ahead, here there are only two terms and the equation will simply be like this. This first term that you see is potential due to its own charge minus X. And the second term is the contribution due to this outermost shell at the location of the inner shell. When we add both the contributions, we get the answer is 0. Solving this, we get X is equal to Q divided by 2 power n minus 1. And therefore the charge on the innermost shell, the answer is actually minus X, which is minus Q divided by 2 power n minus 1. Now I am leaving one thing for you to do. Think what would happen if n tended to infinity. If n tends to infinity, X will become 0. How do you physically reconcile this? Try to think about this. I hope steps in this solution are clear, and if you like the video, like, share and subscribe. And as usual, till the next time, stay safe and stay healthy you all.